Good afternoon from Washington, D.C. This is Ed Salzberg. I'm the Executive Director of the Security and Sustainability Forum, and I welcome you to another webinar in a series with Lightworks at Arizona State University as part of our Fast Forward to the New Carbon Economy series. This one is called Towards a 20 Gigaton Negative CO2 Emissions Industry. We're really looking at the industries of the future, how to get carbon out of the air, and what industries are going to be thriving in a new carbon economy. With different processes, different markets, and really different business practices. We have just an all-star cast to talk about this important topic. It's going to be moderated by Klaus Lackner, who runs the Center for Negative Carbon Emissions. He's really been a leader in negative emissions for more than 20 years. Some people call him the father of negative emissions, and he's just one of the smartest and most articulate people I know in the physics of climate and what we need to be doing to move forward. Dr. David Babson is with the Department of Energy's Advanced Research Projects, ARPA-E, and he runs a program that talks about and looks at the 20 negative emissions goal and the industries and technologies that are coming up in order to be able to achieve that. Gina Amador is a co-founder of Carbon 180, which is a policy and technology accelerator. They really are the leading organization in developing policies or convening folks that are working on policies in negative emissions and low emissions and furthering technology in that area. Bruno Sarda runs the Climate Disclosure Program. Hundreds of companies disclose their sustainability programs and their carbon reduction and greenhouse gas reduction through that program. His voice is really important in this session. And then finally, Nori Rajvanshi is a staff scientist with Siemens. Siemens is doing really a groundbreaking work in sustainability, in infrastructure sustainability, and Nori is leading programs at the municipal level, some really innovative programs. Municipalities are really at the heart of much of the carbon emissions reduction that is necessary, and Nori is a leader there. She's also a contributor to Drawdown with Paul Hawkins, so I just congratulate you on that. Just very quickly, if you don't know the Security and Sustainability Forum, we run webinars like this, many of them with Arizona State University. Just please go up to our website, SSF Online, especially in the archives. Everything we have is free, and the education is just really incredible. The one conference I go to every year is the National Council for Science and Environment, Sound Science, Informing Public Policy. One of my favorite topics. I just encourage you to come to Washington if you're not here in January. Anyway, it's worth the trip, and NCSE offers a 15% discount to the conference. It's an incredible discussion, and it's just worth the effort to come, and the discount brings the cost down into the low 500s. It's quite a bargain. We got a ton of webinars coming up, and you can download these slides now in the GoToWebinar window. I'm not going to go over any of these, but just take a look. The ones in blue are live, and the registration is open in all of those. Here's how the session is going to work. I'll be introducing Klaus very quickly, and Klaus will set the stage for the importance of this topic and kind of look at the weaving of these speakers. Then each of the speakers will go for 10 to 15 minutes with a briefing that should fit together. I think you're going to learn a ton from these folks. Then we'll, at the end of the session, we'll open the questions to the audience, and you can write your questions into the GoToWebinar box now or at any time along the way. I just encourage you to do that. And then at the end, I would just ask Klaus if he would ask the panelists just for a summary statement. What they think is most important that they can transfer to you, or an observation that they have, and then I'll just close the session out. As I said, you can download the slides now. The video will be posted shortly. And one thing that I just ask you to take seriously is the exit survey. It's very important to us that we get your feedback. It's really the only thing we ask of you to come to these, what I think are incredibly educational and free sessions. So with that, let me turn this over to Klaus, who is going to set the stage for this webinar.
Well, thank you very much for having me here and give me a chance to moderate and put my 5 cents worth in on this question. I think moving from climate change is a serious problem that will need to be solved we need negative emissions is actually a big step beyond where we were before. And I think it has taken a long time to get there. For the longest time, we thought maybe if we just reduce emissions a little bit, the problem will get better. But if you start looking at CO2, it piles up in the environment. Once you have it there, it will just stay there, and it will stay there for a very long time. Roughly half of it will be there for thousands of years. The first half goes away relatively fast. So therefore, this is really a stock problem. And so it's not good enough to stop, to slow down and just be a little better at energy savings, a little bit more efficient. We actually will have to drive emissions to zero. And that probably was a good statement to make in 1990 or possibly even in 2000. But by now, we have waited so long that it's actually not good enough anymore to think of the problem as we need to stop completely. We actually will have to come back and go back. And you can see this quite nicely from the IPCC report, which came out a little more than a year ago, where people actually started to analyze what would it mean to stop at 1.5 degree warming. And as a matter of fact, most of the scenarios which end up below 1.5 degree by the end of the century are scenarios where we stabilize CO2 in the atmosphere below 450 parts per million. So you could now ask, how hard is it to do that? Well, in 1800, we had 280 parts per million. We gradually started to go up. Recently, we have crossed the 410 level, and we are going up at about 2.5 ppm a year. So if nothing else changes, we keep doing what we are doing, we will be at 450 ppm in about 16 years. If we allow for the fact that we actually grow 2% a year, we end up actually reaching that number in 13 years. There's no practical way that we can actually stop things that fast. Given the fact that the economy worldwide grows roughly 3%, if we wanted to halt CO2 the level at 450 ppm, emissions would have to drop. Carbon intensity, the amount of emissions per dollar of GDP worldwide, would have to drop every year by 9%. If you think that's hopeless and hard to do, wait another 5-6 years, and in 2025 ask the question again. At that point, it's going to be 14%. So in other words, we have lost the opportunity to say we simply slow down until we stop, and we stop at a safe level. We now have to deal and manage with an overshoot and come back down. My guess is we in the end have to come down by about 100 ppm. And if you work that out and allow for the fact that if we come down, the ocean will give its half back too, and the biosphere, they will give their half of the total CO2 back too. We are talking about 1,500 gigatons of CO2, which will have to be removed and stored somewhere. So this is an enormous challenge. I would argue, ultimately, we have a waste management problem on our hand. For every ton of carbon coming out of the ground, another will have to be put away. And it turns out we have done this now for so long that we cannot ignore the pile of garbage we already left behind us. Now, once you have that requirement, of course, wherever you have a use for that CO2, wherever you can recycle the CO2, by all means, you should do that. So we need to figure out how to create negative emissions. We need to figure out for people to actually deliver those negative emissions, put them somewhere and put them away, and give people agency so that in the end, maybe you can buy carbon neutral gasoline because somebody put the 20 pounds of CO2, which are generated by burning a gallon of gasoline away. But at the end, we will have to close the cycle and probably make synthetic fuels, which don't even involve petroleum or fossil carbon anymore. A lot of things are happening in this space. This all has started fairly recently, but it's really accelerating. And what I find so exciting about this particular session today is that we hear from 4 very different groups and with very different approaches to the problem, who all make incredibly important contributions to actually solve this problem, because this is not one group's problem to solve. It really needs a lot of people coming in. So ARPA-E comes in, policy workshops, so Carbon 180 comes in. Then you have to figure out how do you actually introduce this to industry, and you will hear about that. And then ultimately, what can you actually do on a practical level as a company developing technologies in there, and you will hear all about this. And so without any further ado, I pass this on to David, who can talk about ARPA-E and what the cutting edge research in this field can contribute to this problem. David.
Thank you, Klaus. Sorry about that. I was on mute. Hopefully everyone can hear me now. Thanks for the opportunity to speak to you today. I'm going to talk about the 20 gigaton carbon removal industry and how ARPA-E thinks about this. So I'll start by talking about, let's see here, I can't advance the slides. Let's see.
If you just click your mouse, let me move something out of the way. You should be able to do it right down here at the bottom too, the front and back arrows.
Okay. Thank you. I'll start with talking about what ARPA-E is. ARPA-E is an independent agency within the Department of Energy that was established in 2007 and began receiving funds in 2009 as part of the stimulus, modeled after the Defense Advanced Research Projects Agency, or DARPA. It funds high-risk, high-reward, transformational types of research projects that have moonshot targets. The types of research that we are interested in, of course, focus on energy and specifically decarbonizing the energy system and our fuel systems to maintain economic prosperity in a future world where we are a circular carbon, low carbon, and even negative carbon economy. And so specifically the types of problems we are trying to solve deal with resiliency for the energy grid, economic development, affordable sustainable energy, leadership in science, and of course climate change. And this is the thing that I think a lot about and contextualize a lot of the thinking for program development when I'm doing that. ARPA-E has funded over $2 billion worth of research, funded hundreds of projects. Many of those projects have been transferred into new startup companies, different ideas. It's led to many patents and many papers, and you can read all about all the successes of ARPA-E online, and we continue to move forward. ARPA-E doesn't operate with a strategic plan. The programs that are developed and administered are driven by the ideas of program directors that have a set term limit in the agency. They come in with an idea or a number of ideas, they develop those programs, they implement those programs, and then they move on in typically within 3 to 5 years. And so the life cycle for individual programs begins with stakeholder engagement and workshops. It's followed on by the funding opportunity, and by the end of the first year, typically program directors have selected and begin administering the projects that are selected under their program. So it's a very rapid turnaround time, and there's a short duration for the projects, but we really want to achieve big outcomes, and it's really ambitious research, and it's really fun. I will offer the caveat right now that all of the programs and a lot of the ideas I'm going to be talking about today are in this very early phase, and no program is a program until it's a program, and no money is available for research until the money's available. So these are all ideas. They could become new programs, and this is how we're thinking, and I just want to give you that up front. ARPA-E's portfolio currently kind of divides its projects into 3 areas, and I'd like to expand this to include a whole new area that's on negative emissions or carbon management and those sorts of things. So to the actual content. Now, obviously, it's not going to be breaking news to anybody that's joining this that climate change is real. We can measure the surface temperature anomalies, and the data suggests that this isn't a hoax. It's actually quite serious, and we know what's causing it. We know that the accumulation of carbon dioxide from the continued combustion of fossil fuels in our energy system is driving up the parts per million, as Klaus was noting, now well above 400 parts per million. And the precision that our measurements of carbon dioxide in the atmosphere have allowed us to correlate the known temperature rise to human activities, and that is without question. And the cure for this, the path that we need to follow to reduce emissions and to keep global temperatures below 2 degrees or even 1.5 degrees, require significant emissions reductions, moving through net zero emissions just after mid-century, and then arriving at an economy that is capable of removing and stabilizing more carbon that it emits. And the amount of negative emissions that contribute to the overall emissions, they come online well before the crossover point. So we need to rapidly think about, developing and expanding negative emissions immediately in the near term to help contribute to the net emissions that we see. And these negative emissions targets are quite ambitious, even for them. For what we have now, we would need to achieve megaton scale carbon removal capacity by next year, gigaton scale carbon removal capacity by 2030, and by 2100 we need to have the capacity to remove about 20 gigatons of carbon from the atmosphere per year. And 20 gigatons is a lot. To give you some sense of how big 20 gigatons is, let's consider the fact that the US trucking industry moves about just 9.8 gigatons of materials per year. US pipelines transport only 3 gigatons of material per year. And then throw in the mix the global cement industry and the global iron ore industry, and we get in the area or in the range of 20 gigatons per year. It's a truly massive amount of material flow, and that would be equivalent to about 55,000 Empire State Buildings per year. It's enormous. To put this in dollar terms, if we were able to remove carbon dioxide from the atmosphere at $100 per ton, and assuming that the United States was just paying for it all, these would be global, but to give you a sense in US dollars, the amount of the cost for removing 20 gigatons at $100 per ton would be 3 times what we spend on defense, 2 times what we spend on federal healthcare programs, or 2 times the amount of dollars that are paid out in Social Security benefits. So this is a quite substantial, large amount. And there are a number of different solutions. There are biological solutions, strategies that research could be invested into basically leverage the existing carbon cycling capacity of natural systems, and then deploy technologies to augment their ability to improve photosynthetic efficiency or to sequester more carbon. And specific research areas could include looking at coastal blue carbon and aquatic systems, forest and land management, soil carbon sequestration, or soil amendments and nutrient management. Another approach are engineered solutions. These include things like direct air capture, and then once you remove the carbon dioxide through an engineered system, strategies to stabilize it include enhanced weathering and mineralization. That can actually be a form of direct air capture itself, or research avenues into utilization. And a third and final approach that I'll mention are hybrid solutions. In hybrid solutions, the natural carbon cycling capacity of biomass systems and ag systems are connected with downstream engineered systems to ensure that the carbon that's removed in the feedstock production is not put back into the atmosphere. And these types of systems include bioenergy with carbon capture and storage, perhaps engineering new types of materials from biomass that could displace steel and concrete, such that the cities of the future could actually be storing carbon in the infrastructure around us, or things like biochar. And the current economy that we have is very diverse, and the diversity of our climate presently supports different types of industries in different locations. For example, in Colorado, where I'm traveling this weekend, they have a very robust skiing industry there in the winter. And in Massachusetts, they have a very robust fishing industry because they have of the coast there. And the local climate drives the different types of economies. Now, one thing about all of the industries in all of these areas is that they have all benefited from low-cost fossil fuels that have contributed to the climate conditions that we are experiencing now. And so it shouldn't be a surprise to anybody that the single industry that is going to need to clean up for the entire accumulation of the industrial economy's contribution to atmospheric carbon would be larger than any single industry. And therefore, that industry itself will need to be widely distributed, and the technologies deployed will need to be adapted to the environments that they fit best in. In fact, all of those different research areas that I talked about, whether it's biological, engineered, or hybrid solutions, there's no single silver bullet technology. All of those different technologies need to be developed and adapted to the environment that they are going to be deployed in. So with that being said, I think that's a good primer for the discussion that we're about to have. And I can run through very quickly some of the efforts that ARPA-E is thinking about developing, and then I'll turn it over to the next speaker. So ARPA-E kind of views things, and I view the development of my program in two different ways. We need to make sure that we can do more and make more with less. We live in a carbon-based economy, and we need to make sure that we can produce the carbon-based things that we have more efficiently, and we also need to remove carbon. As Klaus was noting, it's not just a matter of us figuring out a way to significantly reduce our emissions. We have come to a point where we need to, significantly reduce our emissions, cut those down to zero, and then also, engineer strategies to remove and manage carbon. And we're going to need to implement numerous strategies simultaneously and develop many technologies all at once. And no single program or set of programs that I can run would do all of that in and of themselves. So we need to have more research and more people thinking about developing new programs in many, many different areas to help promote a carbon negative economy. Two of the programs that I inherited at ARPA-E include Terra and Roots. The vision for these programs were to engineer feedstock crops for a future bioeconomy that could be highly efficient and even promote carbon negative feedstocks for the bioeconomy. And some of the programs that I want to develop now are to take the technologies for things like Terra and Roots and connect those technologies with platforms that can analyze data for feedstock production and carbon removal to actually connect ag production to a potential future carbon farming industry. And we're trying to do that by developing technologies to enable that in a program we're calling Smart Farm. Other potential programs include strategies to, once you produce feedstocks very efficiently, how would you make sure that when you convert those feedstocks into fuels, chemicals, products, materials, bioplastics, how do you make sure that the carbon that's in those feedstocks finds their way into the final product and there is no carbon loss in the conversion? So in this program, we're actually thinking about how do we re-engineer cellular metabolism such that it is carbon efficient and that it can leverage low cost electrons to do it. And finally, a program that I might be calling NEAT is Negative Emissions Advanced Technologies. And in this program, we would seek to actually go through some of those solution sets that I mentioned earlier, biological solutions, engineered solutions, and hybrid solutions, and identifying critical barriers to deploying those technologies at scale. And that's ultimately where we would get to in a final program. So with the amount of time that I've used up talking to you, I think I'd like to stop here, and I will click to my last slide so that I can give you the information, my contact information, and be happy to take questions at the end on any more of these specific programs. But I gave you the summary of the big three, and we'll go from there. So this is me. Contact me here. I have my email address, my phone number, or you can follow me on Twitter, and this is my Twitter handle there. So thanks. And the next speaker up is Gianna from Carbon 180. So I'll turn it over to her.
Okay.
Hi, folks. Thanks for the introduction, David. I'm really excited to be talking about this topic today. I am the co-founder and managing director at Carbon 180. We're a nonprofit whose mission is to champion carbon removal solutions through science and innovation. So we think a lot about the full portfolio of carbon removal solutions and how we can use those solutions to help fight climate change. Oops. So I think David did the work of a lot of my slides here, so I'll just briefly touch on a couple of them. But I think Carbon 180 was really started under this sort of fundamental realization that reducing emissions won't be enough, that over the course of all of our work to fight climate change, the science was coming out, and particularly the IPCC assessment reports, the fifth assessment report that showed pathways to 2 degrees Celsius were saying that we simply could not reduce emissions, but we also had to actively remove carbon from the atmosphere. And that was sort of the impetus for Carbon 180 starting about 5 years ago now. And I think one of the things that we've sort of come to realize beyond just this sort of inherent need for carbon removal to fight climate change, but that we actually have this incredible opportunity to harness carbon, which isn't inherently a bad thing. It is a fundamental part of our world. It's just sort of in the incorrect place right now, and that's in the atmosphere and in the oceans. But really, carbon can be a good thing, and we can harness that carbon and transform it from a liability to an asset and from a pollutant into a resource. And so we're really interested in harnessing that opportunity to create a new carbon economy. And this is an economy that sequesters more carbon than it emits. And it really is about this idea about total economic transformation, where we see not just the energy industry transformed, but also agriculture, manufacturing, forestry and land use, industrial decarbonization. And we really see the potential for carbon removal to change the way our world functions beyond just simple emissions reductions and help drive the economy of the future. So I think I'll start off in sort of the depths of my presentation thinking about where we are today and what solutions we have. I think David did a really great overview about the types of solutions we have on the biological side, the engineered side, and the hybrid solutions. And I just like to think about, this high level of how do we really chart a pathway towards that 20 gigaton negative emissions economy. And so we have all of these solutions: direct air capture, soil carbon sequestration, forestry, enhanced weathering, carbon utilization, or what we call carbon tech, bioenergy with CCS, and a number of other solutions. And really, where did these solutions fall across their sort of development trajectory? And so I like to use this framework called technology readiness levels, or TRLs. And so it really maps the technology development process from research and just sort of the original concept and ideation and validation of that technology all the way into commercial development. And this framework doesn't perfectly fit all of the solutions, and it's traditionally used at the Department of Energy or when we think about technology development specifically, but I hope that it's helpful for the audience to think about where we are in terms of the development of these solutions. And I think you can see from this little chart that we actually have some solutions that are, being deployed at their first commercial demonstration projects today. Solutions like forestry that we have a lot of experience with and feel really comfortable in scaling. And then other solutions that still need more development, things like enhanced weathering, even some of the soil carbon approaches, while some are ready to be deployed, for example, cover crops and low tillage systems in the Midwest are very common, are used in commercial operations, but we still have some soil carbon approaches like plants that can grow deeper roots or perennialized versions of crops that, of commodity crops like soy and wheat, that we still need to do a lot more sort of technology development on and testing before we get to that big scale question. And I think this hopefully gives you an idea of sort of where the field is now. And I think the rest of my presentation is going to focus on really how do we move these solutions across the TRL stages and help us really get to that new carbon economy and that opportunity that we all want to harness. And so I just really wanted to talk about the barriers that are preventing us from getting to that scale. So I think the first is high cost. A lot of the solutions, particularly on the engineered side, are very expensive today compared to other climate solutions. So direct air capture is estimated to be around $500 per ton of CO2 today, with the ability to potentially bring that cost down to $100 to $300 per ton of CO2. But it really is going to take significantly more research, testing, deployment, and economies of scale to get these solutions down to a cost where we can actually finance the deployment of these solutions. There are also social and environmental impacts beyond just the pure carbon effects. So when we're thinking about deploying solutions like bioenergy with carbon and capture and storage, we need to think about the land use and land rights changes that happen when we are thinking about expanding our world and our global forest carbon stocks. And then finally, I think there is some science risk that goes along with these solutions. I think this is particularly around making sure that we can monitor and verify the carbon sequestration that happens. And this is especially important on the land use side when we are managing carbon stocks and fluxes that are very difficult to measure, especially measure efficiently and cheaply, and also making sure that we protect those carbon stocks over a long period of time and that we are making them less vulnerable to reversal in a time where climate impacts are actually going to be turning that sink of carbon into a source. And so we need to make sure that any investment that we do on the land sector side is very transparent and protected so that it actually supports fighting climate change. So I think the key question that I'm hopefully drumming into your guys' head is how do we bring these solutions to scale? And at Carbon 180, we think about making change in a number of different ways, but a big chunk of our work is focused on policy and using policy as a tool to address the three barriers that I talked about just briefly. Oh, sorry, the slides are a little stuck. So I like to think about the way that the federal government can support scaling these solutions, and I think of those levers in three buckets. The first is research, development, and demonstration. The second is incentives, and this is really about encouraging the private sector to deploy solutions through tax credits, loan guarantees, cost shares, or other market mechanisms that incentivize outside actors to deploy solutions. And the final lever is infrastructure, and that's financing shared resources to help grow a sector or a field. So I'm just going to run briefly through each of these different levers, where I think we are today and where I think we need to go. So in terms of research, development, and deployment, the National Academies of Sciences in 2018 released a report called Negative Emissions Technologies and Reliable Sequestration, a Research Agenda. And they outlined the research needs for every carbon removal solution with the exception of ocean approaches. And the conclusion that they came to was that the US federal government should be investing significantly more resources in research and development than they have been today. And they estimated that would be on the scale of hundreds of millions of dollars per year. And just to give you guys a sort of greater granularity into what the National Academy said, I added this chart on what they suggested for direct air capture research and development. And you can see that in some cases, they're recommending up to $250 million per year in research funding, which is significantly above the total cumulative investment in direct air capture that we've had to date. So I think this is a huge need and something that Carbon 180 and a lot of other nonprofits who focus on policy are working on today. And just to give you an idea of where we are, there's been about $6.5 million in funding for direct air capture research at the Department of Energy. The Department of Energy has also funded a cost share support for a bioenergy with CCS plant in Decatur, Illinois, which is actually an ethanol plus CCS plant. They've also funded about $72 million in carbon utilization. And as David mentioned, there's the ARPA-E Roots program, which gave about $36 million focused on agriculture carbon sequestration. At the USDA, there is also research on carbon sequestration happening, particularly at ARS, the Agriculture Research Service, about $45 million to explore the intersection between climate change and agriculture. And then finally, at the US Forest Service, there's about $6.6 million for research that's focused on improving forest management and wood utilization. So as you can see, the amount of funding that has been invested to date is significantly lower than the National Academy's recommendation, and something that we think about very seriously. The way that we would go about increasing the funding for these programs is through the annual budgeting process, through appropriations and authorizations, and that's something that we've been working on in collaboration with other nonprofits and with the Carbon Capture Coalition to try to increase funding for these solutions. You'll note that the Senate Energy and Water Appropriations Bill came out this week, and they included specific dedicated funding for direct air capture at the level of $60 million. So it's really promising, and I think Congress is really interested in advancing some of these solutions, but we just need to scale that research much more quickly than we are today. In terms of incentives, there are two big incentives that support carbon removal solutions. The first is 45Q tax credit, which is a production tax credit for carbon capture and storage that provides an incentive up to $50 per ton of CO2 for permanent storage and $35 per ton of CO2 for beneficial reuse. And this is a really important price signal for people who are developing engineered carbon removal solutions that the federal government is willing to support that permanent sequestration. On the biological side, the 2018 Farm Bill actually had a number of big wins for carbon sequestration in agriculture. The first is that it established soil carbon and soil health within the existing Conservation Stewardship Program and the EQIP Incentive Program. Those are both programs that support the finance and technical assistance that farmers need to implement carbon sequestering practices. So it's great to see that they're starting to incorporate a more climate-driven aspect into those two programs. It also funded soil health demonstration trials at the order of about $10 million and provided some funding for CO2 use and biogas around for rural energy. On the infrastructure side, I think the sort of only big piece that we see today is the Use It Act, which is an act that has both been proposed in Congress and is included in the National Defense Authorization Act that finances extra CO2 pipeline infrastructure and regulatory changes to support that infrastructure build out. And that's a really key piece if we're really interested in building a 20 gigaton scale industry, is to make sure that we have the infrastructure to transport CO2 and to develop the carbon tech products that we need on that scale. And since I know I'm running low on time, I'll just touch really briefly on state action. The federal government has sort of the biggest purse and the biggest research and the biggest research programs to really support carbon removal solutions, but there is some action happening at the state level. The California Low Carbon Fuel Standard is a really powerful incentive to help fuels that are created from direct air capture or other carbon sources. And those credits are currently trading at about $200 per ton of CO2, which is really high and a huge price signal for direct air capture technology developers. And a number of states have also been working on healthy soils legislation. And you can see from this map that a number of states have passed, have legislation draft or legislation pending around healthy soils that are often directly linked to carbon sequestration in soils. And so I think this is a really, promising example of the way that local, state, and federal, and even international frameworks can work together to sort of drive the creation of these solutions. And then the last thing I'll leave you with is just that on the horizon, I think there's a lot of potential for increased support for these solutions through policy. The 2020 Democratic primary has been a huge platform for these candidates to talk about climate change, and we're seeing a number of them, including Beto, Buttigieg, Biden, Delaney, all include carbon removal in their climate or rural economic development plans, and that has been really promising to see carbon removal really rise to that level of conversation around climate. I think there's also a potential for carbon removal to be incorporated in the Green New Deal and other climate policy in the future. And one of the things that we really think about at Carbon 180 is we've been able to make a lot of near-term progress on increasing research funding or getting some of these incentives in place. But really, if we're thinking about getting to that 20 gigaton level, we're going to need to do more coalition building and build a sort of movement that is bigger than what we currently have. And that's going to take a lot of environmental justice and labor engagement to make sure that we're developing these solutions in a way that actually benefit the communities in which they're being implemented. And that's all I have for you. I just want to encourage you guys to check out our website at carbon180.org. We are launching a fellowship program for entrepreneurs who are interested in carbon removal on this Friday. So if you're interested, please apply or feel free to subscribe to our weekly newsletter to learn more. Thanks.
Gianna, thank you, David. Maybe we now can move on to the next step. How do we actually implement a 20 gigaton negative emissions industry?
Well, thanks, Klaus, and yeah, very interesting presentations from David and Gianna. What I'll do will be maybe a little bit different in the sense of, again, to Klaus's point, how do we kind of operationalize this in industry, and then frankly, how do we create visibility into it? I think I'm having the same problem as David. I don't seem to have controls for the slides. So maybe if you can move me to the next slide.
Okay, great. Bruno, I just gave you slide control. If you click twice on your mouse, you should be able to do it. We're done.
Oops, okay. There we go. Okay, I see them now. Great. So
back to the bottom.
Got it. Thank you. I see them now. So I think, again, a lot has been covered here, and in the interest of, I think, moving to the panel, I'll work quickly through these. Again, the scale of the challenge is known. You know, the science clearly tells us that the need for not just action, but urgent action is more pressing than ever, not just because our regular economic activity continues to put CO2 in the atmosphere, but because the natural systems that have been also kind of balancing that for a long time, whether it's the oceans, the land, are also at risk. And so these systems clearly need to be protected. What we do at CDP is we are a global nonprofit. You know, we launched the first systemic link between environmental information and financial information nearly 20 years ago. We work with business and investors really at the intersection of the two. We've created the world's basically largest data set on what business is doing and or saying they need to do about transforming their organizations and or their sectors to address the challenge. In terms of numbers, where that starts making an impact is CDP is at the intersection of, again, an enormous set of levers, if you will. We, on the one hand, we work with a group of over 525 investor signatories who collectively manage almost $100 trillion in assets. We work with many large organizations through their supply chains. They collectively spend over $3 trillion a year in procurement and are really shaping the direction of those dollars in the direction of more environmental practices. And then as a result, on behalf of these investors and these large procurement organizations, we had last year over 7,000 of the world's largest companies disclosing very detailed reporting to CDP through our platform. These companies represent over 50% of the global market capitalization across all of the world's exchanges. In addition, we also work with cities, states, and regions, not countries, but anything subnational for disclosures, and now over 600 large cities, including dozens of mega cities around the world, both on their climate risks and opportunities and their resiliency strategies, along with states and regions. And where that starts making a difference then is that basically whatever actually needs to happen and how policies and incentives and all the things we've talked about today, or new technologies, where and how they're deployed, will be disclosed through CDP. And then that data, then how that data is used once we collect that information from all those companies, all those cities, we're nonprofit, we're a public good organization, so this data flows into many things. So whether it's in the policy community, whether it's in certainly the finance community, the CDP data flows into all information systems that and decision systems that now are used in the financial community, not just for equity and fixed income investors, but banks and lenders and insurers to understand the scale of this of both the problem, but also to really start recognizing where opportunity exists, where action is being taken, and to make decisions accordingly. Oops. What that also looks like then is, instead of, or in addition to just feeding data through a lot of different platforms, again, to universities, to investors, to regulators and policymakers, is we also abstract the information we collect to try to bring some light to what we're seeing through, again, all of these businesses. For example, in June, we released a report, Climate Risks and Opportunities report, where we looked specifically of the 500 largest companies, about 300 of them identified basically being exposed to substantive climate-related risks. Over 200 of them specifically quantified those risks in financial terms, saying that within the next 5 years, they believe there's a high likelihood, either high likelihood or near certain likelihood of $1 trillion worth of risk, including about $250 billion worth of stranded assets and asset write-offs. On the other hand, though, is that about the same number of companies also reported that they see over $2 trillion of low carbon opportunities in there. And again, this is highly likely or virtually certain in the next 5 years, including the financial sector that actually sees a huge opportunity to finance this transition, finance these new technologies that are coming forward. So how we work with companies in terms of getting them to focus their efforts and to translate these risks and opportunities into specific actions. Historically, we've helped them work with a variety of tools. At the heart of that is the Science-Based Target Initiative. CDP is basically the interface to business for the Science-Based Target Initiative. To date, there are now over 600 large companies that have set science-based targets. And where that's important, as the conversation so far today has highlighted, is that the science matters, and both the science in terms of what will happen if we don't act, but also the science that tells us all the ways we can act and where action can be taken and where action can be most effective. And so these science-based targets to date have been focused primarily on emissions reduction, right? Scope 1 direct emissions, Scope 2 purchased electricity, Scope 3 indirect emissions, both in kind of the upstream, kind of supply chains, as well as downstream use of sold products, where, for example, for oil and gas, most of their emissions would be in their kind of downstream use of sold products. In addition to initiatives like the RE100, getting now nearly 200 large companies committing to procure renewable electricity or transitioning their fleets to electric vehicles. So all those things clearly are important and need to continue. As we've heard so far today, that's just not going to be enough. And as much as we need to stop emitting as much as we are now and dramatically reduce the trajectory of emissions, the worst risks of climate change will not be averted if we don't find a way to balance that carbon budget through all the tools and solutions available, not just the ones that halt or reduce emissions, but the ones that also start either capturing those emissions at the source or from the atmosphere. The last thing I'll say before I pass the mic is I think something we do at CDP is to make sure that again there's a very standardized, consistent, comparable, rigorous approach to disclosures, to accounting, to measurement. Gianna touched on this as well. And as we introduce these new solutions, these new technologies, organizations like ours will be, very focused on making sure that whether it's carbon removal and other solutions have, robust processes and tools in place to so that the verifiability and the transparency, the accountability of these solutions are trusted. There were for a while lots of different things around carbon credits, carbon offsets that were being used and claimed, some with extreme rigor and process behind them, and many much less so. So again, that's one of the things certainly we'll be looking for as this new wave of tools and technologies and processes, whether again it's nature-based or more technology-based, that effort is really put in for both the transparency in the calculations and the accounting methods, as well as in the disclosure along the way. But I'll stop there for now, and then I'll be happy to take questions later and pass it on to Nouri.
Thanks, Bruno, and thanks, Klaus. So my presentation is a little bit on similar lines to what Bruno was talking about. I'm going to talk about not only Siemens' sustainability efforts, but how we are working in our urban development side with cities around the world, helping them transition to low carbon economies. Basically, first I want to talk about why this is important to Siemens. Why are we working in urban development? So when we are looking at our global strategy, we have identified these 5 megatrends that are not only shaping the world, but are shaping our company's strategy. And in addition to the usual suspects like digitalization or globalization, we have also identified urbanization as one of the 5 megatrends that are shaping our world. We are all aware that about 50% of the world's population currently lives in the cities, and it's expected to go up to something like 68% of the whole world's population living in cities by the year 2050. Cities are currently producing 80% of the world's GDP and consuming about 2/3 of the world's energy.
Nouri, we just lost your sound. Down here.
I have lost my video.
Hold on here.
At zero carbon cities. So basically what this analysis shows that deploying low carbon emissions, low carbon measures in cities around the world has the potential of reducing greenhouse gas emissions from buildings, materials, transport, waste, by nearly 90% by 2050. This is equivalent to about over 15 gigatons of CO2, which includes also decarbonization of electricity. This is a very large amount. I know we are talking about going to zero carbon or even negative carbon, but this is a great start for cities that are struggling with figuring out how they will pay for some of these technologies and transitions that are currently available, not even in future, but are currently at technology ready level that Gianna talked about. So before I go into our work with cities, I wanted to talk about what Siemens is doing as a company. And we are definitely committed to sustainability. I think that's one of the reasons also Ed reached out to us, is that we have a very public, aggressive target of being carbon neutral by 2030 on our own operations. So we are looking to implement this by, of course, energy efficiency programs. We are looking to install distributed energy systems. For example, the site that I sit in Princeton, will likely produce all of its electricity consumption needs from the solar panels that are covering our parking lot right now. But we are also acknowledging that we have over 47,000 vehicles in our fleet. We need to think about those when we look at our zero carbon commitment. We are also supplementing our efforts with purchasing green energy. So we acknowledge that whatever we do internally might not be enough, and we do need to look at renewable energy credits to supplement our efforts. In addition to our own operations, we are also looking at our supply chain. So we are encouraging our suppliers to increase their transparency and putting forth ways that we can choose suppliers based on their decarbonization levels and what they're committing to do in future. In addition to that, we are also thinking about our customers. So we are helping our customers by making technologies and solutions that will reduce carbon in addition to capturing carbon. So we have CCS solutions, we have energy efficient solutions that will be deployed to customers to reduce their own impacts. So next, I want to, the rest of the presentation, just maybe 5 more slides, I want to spend on our work with the urban development. So as I mentioned to you, urbanization is one of the key mega trends that we are looking at. And we basically decided to invest in this to help cities. So one of the ways that we are doing this is through this tool that we developed a few years back called City Performance Tool. One of the needs that we saw during our work in urbanization was cities have very aggressive climate action goals. They have emission reduction goals. They already have climate action plans in place. Many of them are starting to act on it, but it's an overwhelming task. They look at the number of things that they have to do to achieve their goals, such as 80% emission reduction by 2050. And they don't know where to start. They don't know, they don't have really great ways of quantifying some of the technologies that they're thinking about and how those technologies will impact their goal. And they would also like help prioritizing, where do we start? We have this limited pot of money. Where do we go from here? So our tool looks at transportation, buildings, energy sector, and we'll build an emission baseline for the city using over 350 data points. And we look at over 70 odd technologies and levers that can help cities get to their goal. And these technologies, as I have given some examples here, looking at public and private transportation, they're looking at automation of building controls, looking at a decarbonization of electricity production, And in addition to CO2 emissions, we are also looking at indicators such as improving air quality. So what do these technologies do for air quality improvements? And how many jobs would be created if the city chooses to implement these technologies in future? So we have been doing this, as I mentioned, for a little over 4 years now. Already, we've done this analysis for over 35 cities around the world. I most of the times work in North American cities, so I can speak to more details on those. But every city is unique. So even though we have worked in so many cities, we find something different everywhere. There are, of course, some trends that come to play. And in the slide, I'm showing 4 examples of North American cities. And the chart basically shows a waterfall chart of how the city is right now, and with different, many of these 70 technologies that we're able to analyze, how they would look like in their target year, which is most likely 2050. And of course, there are some trends. These trends are not, will not be surprising to the audience. Of course, the decarbonization of electricity and heating is one of the biggest contributor to emission reduction. Closely following is electrification of transport, both public and private. And another one that is emerging as a top performing lever is expansion of public transit and modal shift away from single occupancy vehicles. Just to give you, a little bit more detail, here is an example from our study in Los Angeles. So the city of Los Angeles has a target of reducing 80% of their greenhouse gas emissions by 2050. And our analysis was used by them for updating their climate action plan, which is called the Green New Deal, I think. And some of the technologies, we analyzed over 19 technologies for City of Los Angeles at a very aggressive implementation rate. And some of the technologies like 100% renewable electricity by 2050, as well as 50% of the building heating by electric air-sourced heat pumps, in addition to automation in commercial and residential buildings, and e-mobility. And these 19 technologies together, along with decarbonization of the grid, basically showed that they can, Los Angeles not only can achieve their target, which is 80% reduction, but can exceed it. It's going to require a lot from the city. It's over $300 billion investment in capital and operating expenses, which includes at the bottom, if you see, which includes installing these heat pumps or automating homes, or even over 190,000 EV chargers that would be needed to install to support their 100% electrification goal. And finally, just to summarize, our work in helping cities doing this CYPD analysis has been used in various different ways. So the City of Los Angeles was just one example. There are other examples where
Nori, I just lost your sound. Okay.
climate action plan. So our analysis is helping them set targets or even prioritize what actions they want to take to get to their really ambitious goals of even carbon neutral cities. And then finally, this is my contact information and all of the studies that I mentioned during my presentation, and even Siemens' sustainability targets and on decarbonization and whatever we are doing is also available online. Thank you.
Thank you very much. And unfortunately, I don't know what happened, but I cannot turn my camera on. I get a little squiggly line going around in circles, and I can't turn it on or off at this point. So we have to.
Close, it's on, and we can see you.
You can. I can't see anything. So bottom line is, you have heard a very broad spectrum of very interesting talks, and this leads obviously to a number of questions. I have seen a lot of questions coming in, so let me try to answer some of it and pass the questions on to all of the panelists so they can say something. Let me just say, I said a gallon of gas produces 20 pounds of CO2. Yes, that is right. And it weighs a lot more than a gallon of gasoline, because on the way you picked up oxygen to stick it to the carbon. And that just about tripled the weight of that gallon of gasoline as it goes out as CO2. So one question I have after all of this is 20 gigatons actually enough? And to let my prejudice show, if we want to come back by 100 ppm and do that in 40 years, we need 40 gigatons a year.
Bruno, could you turn your camera on? And
so if the panelists can start getting into this question.
Yeah, I can start. I think, as David showed in his presentation, 20 gigatons is already extremely ambitious. And so I think it's a good target for us to think about realistically what the scale is that we need to be sequestering on an annual basis. But the reality is that we don't actually, like, there is a great deal of uncertainty in what total global emissions will be in 2050, and a great deal of uncertainty about whether some of these solutions will even pan out at the scales that we estimate them to be. So I think there's a lot of modeling that has been done to try to answer those questions, but ultimately we need to be trying to scale this industry as fast as possible. And I think 20 gigatons is a ambitious yet reasonable target, even if it's ideal for us to be to have something even bigger or more audacious. It's important for that to be rooted in the realities of some of the limitations of these solutions. We only have so much energy to power direct air capture, so much land to grow forests, so many farmers who can sequester carbon in their soils, so many olivine rocks that we can mine to capture carbon. And so I think being realistic about the scale while also being optimistic about the opportunity is something that's difficult to balance. But I think at the end of the day, 20 gigatons is reasonable.
I actually do think, if you look at the history of it, that the CO2 estimates we need have consistently over the years gone upwards, because we gradually come to grips with the problem. And if all I'm pointing out is at 20 gigatons a year, it will take you about 100 years to get back 100 ppm. So if you think we have to come back from 480 back to 380, which is not an unreasonable scenario, even after you stopped all emissions, you still will take 80 years to come back at that scale, because that's just the limit we are setting. So I just would like to point that out. I'd like to hear what others have to say. And of course, 20 gigatons is a lot better than 10.
What's unique about this particular industry, first of all, let's just state, even at 20 gigatons per year, that would be the largest industry on the face of the earth. We are predicting that the largest industry on the face of the earth is going to be carbon removal and management in 2100. And therefore, we need to develop the technologies that are going to service that industry such that it can operate energy efficiently and at a low cost. And if we have in place the structure where folks can profit from removing carbon, unlike other types of markets where there are demand limitations that would control how large an industry grows. If the value proposition is there to remove and mine carbon from the atmosphere, what we're saying here is that there is, somewhat of an unlimited, demand that would damper that industry's growth. Unlike any other type of industry, because the amount of carbon that we could remove would always be greater. It becomes almost like an infinite well that wouldn't necessarily cap it at 20 gigatons. And I would argue that if we have the technologies to drive the reduction of carbon dioxide from the atmosphere down, then, and we had the will to pay for the service of doing that, I could see the industry growing much larger than 20 gigatons. And like I said, there's no limit to it. It's not like, people, only have so many tires that they can buy or whatever. So the things are, in other, economic areas, there are limits in demand. In this particular industry, it would be quite large. So, these technologies are applicable throughout many different areas. As Gianna was pointing out, there are limits for each individual type of strategy to remove carbon. But, when you actually look at how we're going to get to 20 gigatons or even larger, it's going to require distributing the cost of those technologies over a number of different technologies. And I would argue that the real business proposition and the person that's going to profit the most from this future industry is the individual that can figure out how to match, removal and cost to different technologies and apply them efficiently in different regions. So.
Yeah, one thing I'll add, I think, there might be maybe hundreds, maybe thousands of people in the world who would have, I think, an informed answer to your question, Klaus. I think what we need millions and billions of people to really understand, how to think about these questions and the various trade-offs, whether it's voting for the policies Gianna was talking about or voting for the candidates, So I think, one thing we learned early on in climate science is keeping it really abstract in language that most people don't use can be limiting to the deployment of these solutions. And I think, the importance of not only transparency and disclosure, but also translation. And I think, David's examples of, so what is 20 gigatons, and just kind of adding up stuff that we could start understanding a little bit more. Wow, it's like all of this plus all of this plus all of this. I think, challenging ourselves also along the way that as we grapple with these really complex decisions, to also remember that it will actually benefit the velocity of deployment. If we also translate this into language, more people will be able to understand, including business. Again, when you're making an investment case as a business, no one business is going to solve for 20 gigaton challenge, right? They're going to solve for whatever challenge is relevant to their value chain, to their marketplace, et cetera. And so that's certainly something that I would like us to do more of as well.
And yes, it will be a fantastically large industry, even at 20 gigatons. But on the other hand, we have also the energy industry in total is on a comparable size, not surprisingly, right? So we will have to deal with these issues in some form. One of the questions which sort of came out of a lot of questions asked, where's your feeling that we actually, at what price, at what cost will this actually work? If you look at air capture right now at $500 a ton, we would bankrupt the world. So the question is, where do you see the cost has to go to before fully scaled up technologies are actually useful? I mean, some technologies clearly are not all that expensive, but they also will not get to the scale. So the question I would have maybe to the panelists is, where do you see this getting interesting? Is it $100, $50? Where do we need to go for this to actually make sense?
Certainly below 100, maybe down to 50. But the real thing to point out here is that the technologies that you can employ that remove carbon for the cheapest amount right now, and there's been some reports that that their natural systems in the ag sector have the prospects to offer a fairly inexpensive carbon removal presently. What's important is to create the mechanisms, incentives to actually drive the deployment of those strategies immediately,
Yes.
while financing the research that's necessary to drive down the technologies in the other space.
Right.
Part of the growth of this industry is going to require servicers of negative emissions to, in their portfolio, accommodate a number of different technologies, some of which cost more than what they're selling the credits for. And they're basically financing the reduction in the cost of those technologies with other technologies that are already in their portfolio that cost less. And so the average of what the negative emissions cost are a function of the scale and the cost of the overall suite of technologies in that portfolio. That's
Yes.
what we have to think about. All too often, individuals, that are working on a particular strategy to do carbon dioxide removal, say direct air capture or soil carbon sequestration or planting trees, whatever it is, are focused on the economics of that particular strategy in the context of what a potential carbon price is. And in reality, in order for us to realize an industry, we have to think of it in aggregate and not as individual pathways. That's how we're going to get there. And I don't know what that price point is, but that is the logical way to start, is to say, okay, well, what negative emission strategies can we employ now that are the cheapest? How do we scale those? How do we think about bringing in others that cost a little bit more and financing the reduction of their costs on the fact that we know that these are less? So
yeah, let me put a pitch in too for the ugly carbon storage or disposal, because I think at this point we are producing more CO2 than we produce sand and aggregate or gravel. So bottom line is we can use quite a bit of it, and if we make synthetic fuels, we probably can use all of it. But if you want to come back down, you will have to find good storage for it. And yes, some of it will be in plastics and building materials, but I think the numbers are again so large that we need to think waste management too. And as I have said in the past, if I leave my garbage out, you will be mad at me and telling me that this year I made 10% less than last year. It's not good enough. We have to figure out, first you have to have no choice but to dispose of it if you don't find a good use for it. And my concern is that we don't give carbon storage short shrift in all of this. And it's not just for coal plants, it's also for negative emissions. Another question which came up quite frequently is the question of the scale and scope of forest biomass in all of its form. Anybody wants to give some answers on that question?
The question being what, Klaus? The capture potential, or
capacity on the biological side, because people do argue about that.
So this is a good opportunity, and I'll let some other people speak, but this is a good opportunity to plug the first phase of funding that ARPA-E announced as part of our Smart Farm program. For the biological sector to be able to offer negative emissions, we need to verify what services they could possibly provide, either in an ag setting or in a forest setting. And presently, our ability to quantify, in the bioeconomy space, for example, field level carbon intensity for feedstock crops, or the amount of soil carbon sequestration that is taking place in forests or what have you, the ability to quantify that with great accuracy is limited by, the available sensing technologies and the cost and the technical challenge of actually quantifying that. So this program seeks to establish through 3 different phases the technologies and the systems and the methods to accurately and consistently with a low cost verify both carbon sequestration and GHG flux in ag systems. And if successful, these sensors could be deployed and could serve ubiquitously throughout both the forest and ag sectors as the lynch point for being able to value ecosystem services, specifically carbon management services from these sectors. So, while there are some good data that suggests that ag sector and the forest sectors provide significant amounts of carbon sequestration, nobody's going to pay for buy the credits if they can't verify them. And so that's why this program is so important, is we're going to develop the technologies to do that. And it will enable a future potential of carbon farming industry, as well as promoting the existing bioeconomy and ensuring that the feedstocks that service it are much lower carbon and perhaps even carbon negative.
That's why I think having a good certificate of sequestration is actually very, very important. Anybody else wants to try to give an answer to that?
Yeah, I'll just add that I think there's a lot of discussion and debate over what the potential of the land sector is, being both forestry, blue carbon, and agriculture. I think it was in 2017, there was a paper around natural climate solutions that was published in PNAS that said the sort of theoretical maximum potential of the land sector is about 20 gigatons of carbon per year. That's a huge number, and that I just want to be clear that that's not only removal, it's also avoided emissions from deforestation, things like nutrient management in agriculture, methane reductions. And so that's not just removal, but I think that's hopefully a nice number for the audience to think about the total maximum potential. The recent National Academies report sort of tried to quantify the scale of land sector emissions reduction or land sector removals for under $100 per ton of CO2. And they said the global potential for forestry was about 2.5 gigatons of carbon dioxide per year. And from the agriculture sector, that was 3 gigatons of carbon dioxide per year. So you can see that there's sort of a huge difference in the estimates from this PNAS paper and the National Academies of Sciences, but it's a question that people are really trying to hone in on. And to David's point, as we get better on monitoring global carbon stocks and measuring and verifying carbon on a project level, those estimates will get more and more exact.
But one thing I may add too is this idea again of, call it payment for ecosystem services or something else. But this idea, at CDP, we have a whole forest disclosure program where we on behalf of investors, solicit 1,500 companies that have very direct activities of causing deforestation through the sourcing of 4 key commodities, right? Cattle, soy, palm oil, and timber. And driving the disclosure of why this deforestation happens and why especially the local communities that have control over these resources, use that as basically their primary source of economic development or income generation. And at the end of the day, if we value these natural resources and their ability to do what they do best, is that there has to be some kind of economic return. So, tying back to your earlier question, Klaus, of what is the cost? At what cost will this start happening? I think for me, it's also a question of value and who will value doing these things more than, doing something that is actually carbon emitting or at least going against the idea of removal.
I have another question which came up in the list coming to me, and this is: how important is dealing with methane or other greenhouse gases in general? Should we just focus on CO2, or do we have to put a significant focus on methane?
Yeah, I mean, it's all of these estimates are actually just normalized CO2 equivalent emissions, and you know, in those estimates, methane, nitrous oxide, other non-CO2 greenhouse gas emissions are included. So, you know, without specifically saying it, we're saying it presently.
I would actually argue that negative emissions make particularly the short-lived greenhouse gases like methane more important, because once you're on a trajectory where you come back at the end, the long lifetime of CO2 doesn't really count anymore, right? The damage is done before you came back. And in that time, you have excess CO2, you have excess methane driving excess forcing. So I think if anything, you should use a larger multiplier, a larger warming potential factor than you do before. Let me answer one question, which was that why is CO2 at 0.04% so important? Well, if you send infrared into the atmosphere, oxygen and nitrogen are absolutely transparent. The two gases which really matter are CO2 and water vapor. And the water vapor goes with the temperature, and there's not much you can do about it. It goes up and down all by itself. But the CO2, they're piling up, and going for doubling of the CO2 in the atmosphere will really change the transport of heat through the atmosphere, and thereby dramatically change the climate. And while 0.04% sounds like an awfully small number, it's not actually all that small. As a matter of fact, congressmen, which are very important in the US, are 2 parts per million. And so CO2 is very powerful when it comes to control infrared radiation. So small numbers may be deceiving on that. But any other things? I think we are coming to the point where we should wrap up. So if everybody can say a few words in summary, what they think is going on and how they see it. So maybe we'll go in the same order as in the beginning, David.
So thanks again for having me. Please feel free to reach out to me. I provided both my email and my contact information. And I would just, you know, like to say from the standpoint of ARPA-E, of course, we think that in the near term, the things that we can actually do to help promote this future largest industry on the face of the earth is develop the technologies that are going to service it such that we can do large scale, industrial scale carbon removal at the lowest possible cost with the greatest possible energy efficiency. And that's what we're going to try to do.
Very good. Gianna?
Yeah, just want to thank everyone for having me and for coming to this webinar, and especially to Ed for organizing this. I think there is a huge opportunity around carbon removal, and it's one of the only places where we're seeing progress on climate policy, especially at the federal level today. And so I think that's one of the reasons why I'm really hopeful and excited to be working on this topic, is because of the huge opportunity to create a new economy that sequesters more carbon than it emits. So like David said, I'm also available for questions. So feel free to reach out to me if you're interested in learning more about this space.
Bruno?
Yeah, I'll echo also. Thanks for putting this on. I think it was hugely insightful. The message I'll leave everyone with again is certainly focus needs to be absolutely continued on reductions, as well as then starting to focus on removal. And then if anybody's interested, and again, this 17 years worth of data we have on corporate actions around their carbon footprints and their engagements with whether it's the carbon markets or their investments in low carbon technologies, feel free to go visit cdp.net about all the research and the data we've produced over time, and any input for example, future questionnaires of how we collect information in the future that could tie to some of the things we talked about today. we have an ongoing consultation period as to how to evolve the CDP data collection process. So we welcome input as well.
Nuri?
Yeah, thanks for including me in this talk. Most of our work so far has been in carbon removal, but we are, as I work with cities more and more, I see them thinking about beyond removal, beyond reduction and going on to removal. So we are venturing more and more into this. We have ARPA-E funded projects as well that are looking into resiliency and CCS. So that's something that will continue. And I have provided links at the end of my presentation on most of the work that I talked about. And feel free to contact me if you have any questions. Thank you.
Thank you, everyone, and a great thanks to Ed for putting all of this on. This has been a great pleasure. I'm glad to learn more about all of this from these discussions. I also would like to point out we have dug ourselves a very deep hole, and one of the things you need to do if you find yourself in a hole is stop digging. So I'm in 100% agreement with Bruno. We have to reduce our emissions, but at the same time we end up having to fill the hole back in. Of course, we don't fill it in as long as we keep digging faster than we fill it. So we have to get these two things together, and we have to get back to a condition at which the climate remains stable. And I think we are past that point, and we will go a lot further past it in the next 50 years. I think what has happened is we live in an overshoot world, and we have to figure out how to minimize this overshoot, and negative emissions in all of their forms are a critical ingredient to make this happen. And I think we all have to pull together and think of this as a system that has to be improved, and there are lots of different things which make that work. You've heard a wide range of different things today, and I think I close with this and hand it over to Ed.
Thank you, Klaus, and thank you, David, Gianna, Bruno, and Nuri. Your backgrounds are really incredible, and I think having conversations about the size of the problem, how much research is necessary in order to move us forward. And I always like Klaus's perspective on the waste in the atmosphere. You would never permit anybody to dump their trash on your lawn, but we certainly do have over the years allowed waste to go up into the atmosphere, and nature is unforgiving. I'm always struck by the size of the problem and the pathways forward, and that we need both technology and we need policy in order to move forward. And at some point, there has to be a tipping point where everyone sees that we all need to pull together across government, industry, and education. I don't think we're quite there yet, but I think that the work that Bruno does is really kind of central to that, and I think he may have the best perspective on where industry is, and the work Gianna does on carbon policy is really critical. And then the research that David talked about is just fundamental for us being able to move forward. So thank you all for a really interesting discussion. And some of the webinars we do have coming up with ASU and others do talk about what it does take from a policy standpoint to move us forward. So I hope you take advantage of the fact that our webinars are free. And we do have a lot of them, so please click those links, take a look, and I hope to see you in other sessions. Also, if you can get to DC for the NCSE conference, like every year, it's going to be an incredible session, and you do get a discount to come. It's really an inexpensive session to really talk to folks that are at the forefront of this industry. So again, thank you all for just a really interesting discussion, and your deep and important perspectives on the area. You bring incredible expertise, so thank you for that. And I thank everyone of the audience members who stayed with us right to the end. We appreciate your attention. And remember to take the exit survey. We ask a question about what role you're playing in the negative emissions, the negative greenhouse gas industry from whether you're just thinking about it, or you are an entrepreneur, or you're a researcher, or you're funding different projects. We'd like to hear from you, and would like to come back and re-engage on that information that you give us. So please take the exit survey. It's really important to us. So again, thank you, Klaus, and the panelists for participating and providing just really important perspectives.
Thank you.
And with that, I'm going to end the session.